All right, so this video is the Unit 7A handout. Let me go full screen here. Okay. So the idea of this video is going to be something called transformations. The way that they work is you get these rules that are written kind of like this. Like xy turns into 2x 4y plus 1. Something like that. And so what this rule does is it actually tells you how to take points and turn them into new points. So like if one point was 1, 4, and I wanted to transform it using this rule, then my x-coordinate gets doubled. So that becomes 2 times 1 is 2. And then the y-coordinate, I'd multiply it by 4 and then add 1 to it. So 4 times 4 plus 1 is 17. So the point 1, 4 would get transformed into the point 2, 17. What you often do also is, if I call the first point A, then you call the second point A, and then this apostrophe, but it's called A prime. And it tells you that it was that image of what A used to be. So A turned into A prime. So our goal is to kind of look at some different transformations that are common ones and how they represent, like, what does that actually do visually to the points. So let me get rid of this. So I'll just delete that. Nope, I'll just erase it. Okay, so in number 1 here, we've got, oops, there we go. In number 1, we've got this transformation rule given to us. xy turns into negative xy. So we're going to try it with 3 points. A14, now notice the only thing that changes is the x becomes negative. So A14 is going to turn into A prime. I'm just going to change the sign of the x and keep the y the same. In B, same deal, B prime, I'm going to change the sign of the x coordinate, negative 2, and the y stays the same. And then C prime, I'm going to change the sign of the x coordinate, so that becomes positive 5, and then the y stays the same. And if I plot those points, A prime, negative 1, 4 is up here. So here's A prime. B prime is negative 2, negative 3, so it's down here. And C prime is 5, 1, it's way over here. And what this is, if you think about it, what's happening is the y stays the same, the x flips signs, and visually what's happening is we're bouncing these points across the y-axis and getting a mirror image of it. So the math term for that, the way that I'll write this up, the transformation xy turns into negative xy. That represents a now the math term for bouncing it across is reflection. And in this case, it's across the y-axis. So that's reflection across the y-axis. By the way, a lot of this stuff is heavily related to computer programming, graphics, stuff like that. Video games use things like this all the time. Okay, so let's look at 2. So 2 is going to be another type of transformation, and this one's almost the same, but instead of making the x negative, the y changes sign. So if we apply these to the same points that we used before, A prime now, the x stays the same, but the y changes sign. B prime, the x stays the same, but the y changes sign, so now it's positive 3. And then C prime, the x stays the same, but the y changes sign, so it went from 1 to negative 1. And if I graph those guys, 1, negative 4 is down here, so here's A prime. B prime is 2, 3, so right about there. And C prime is negative 5, negative 1, so that's about here. And if you look at these guys, what's happening here is we're bouncing across the x-axis instead. Whoops, that goes the other way. It went from A to A prime, bounced across the x-axis, bounced across the x-axis, bounced across the x-axis. We got mirror images over there. So in this one, the transformation xy turns into x negative y. That represents a reflection again, but this time it's across the x-axis. So notice this is often confusing to students. Notice in the first one the x's change, but you're reflecting across the y-axis. In the second one the y's change, you're reflecting across the x-axis. So that seems a little backwards to students, but if you graph it, it's more obvious. Okay, let's take a look at the next page here. So on the next page, we're doing a different kind of transformation. Okay, so this one, we're taking points x, y, and turning them into x plus 3, y minus 5. So let me write the rule right here. xy turns into x plus 3, y minus 5. And we've got these 3 points, negative 1, 2, b is 3, 6, c is 4, negative 1. Okay, so if I take negative 1, 2, if I take negative 1, that's the x, and I plug it in here, the new x value, the new first coordinate, will be negative 1 plus 3, that's going to be 2. Oh, and I'll call it a prime. So a prime will be 2, and then if I take the 2 and plug it in for y, I get 2 minus 5, negative 3. So a prime is going to be at 2, negative 3 right here. A prime, 2, negative 3. Okay, if I do the same thing with 3, 6, if I plug in the 3 for the x up here, then I'm going to get 6. So b prime will be at 6. And if I plug in the 6 for y, I'm going to get 6 minus 5 is 1. So this is at 6, 1. So 6, 1 right here. So b prime is at 6, 1. By the way, AB turns into A prime B prime. So any point on this line moves to that new green segment there. And then C prime, if we do the same thing, let's see, 4, if I plug it in for x, it's 4 plus 3, so that's 7. And then if I plug in negative 1 for y, y minus 5, that's going to be negative 6. So if I plot 7, negative 6, 6, 7, negative 6 is right here. So here is the new triangle that you get. And if you think about it, all that really happened was this triangle got moved over a few units to the right and then a few units down. Well, it got moved over 3 units to the right and 5 units down. So this right here, xy, turns into x plus 3, y minus 5. That represents a, and now the term for moving stuff around, just sliding things around, translation. Translation or shift of 3 units left, or no, sorry, 3 units to the right and 5 units down. I'm just going to use RL and UD for up, down. Okay. And by the way, if you think about it, if all I'm doing is sliding this triangle around, I'm not actually stretching it out in any way, then the original triangle here is going to be congruent to this triangle there. All right, let's take a look at 4. So number 4, you want to change the unit circle. The unit circle, by the way, has points with radius 1. These are all 1 unit away from 0, 0. The center is 0, 0. So if I label this A is 1, 0, and then B here is 0, 1, C over here is negative 1, 0, and then D is 0, negative 1. So the goal now is to stretch out the circle by a scale factor of 2, stretching it out from the origin. So that means that I'm going to take the circle that I have and stretch it out so that from the origin, the distance to here now gets doubled instead. So the distance to here now gets doubled. So A prime is going to end up at 2, 0. B prime is going to end up at 0, 2. C prime will end up at negative 2, 0. And D prime will end up at 0, negative 2. And then if you connect those, you're going to get just a bigger circle instead. And notice, they're not congruent circles, but they are similar circles. And when you stretch something out like this, it's called, you can call it a stretch, or you can call it something called a dilation. You might have heard of dilating your pupils when you go to the eye doctor. That makes your pupils bigger. So the opposite of dilation, by the way, is called contraction, or you can call it a shrink. So in this case, the rule here, the xy, what we did was we actually doubled everything. So the x's got doubled, and the y's got doubled. And this represents a dilation or stretch by scale factor of 2. If I wanted everything to be tripled, then I just do 3x and 3y, and then I get a circle 3 times as big as the original. So in number 5, we're going to try dilating this thing by a scale factor of 2. So I'm going to take all my points x, y, and I'm going to double them, 2x, 2y. And if we do that, so A is at negative 1, 4. If I double them, I'm going to get 2 times negative 1 is negative 2. 2 times 4 is 8. So A prime will be at negative 2, 8, which is about here. A prime, negative 2, 8. And then B, if I double the 3's, I'm going to get 6's. So B prime will be at 6, 6, which is about here. And then C was at 5, negative 1. So if I double that, I'll be at 10, negative 2. So let's see, 10, negative 2 is here. And then if I double the coordinates for D, I'm going to end up at D prime, which is 4, negative 6. So let's see, 4, negative 6, about there. And if you connect these guys, let's see, let me choose that green here. When you connect them, you're actually cutting through, in this case, the original shape. It is twice as big, but notice that in the previous problem, the small circle is right in the middle of the big circle. In this one, that's not the case. So the way that the stretches work is you're stretching from the origin, so everything gets pulled out from here. So really what's happening is if you figured out, well, how far is it from the origin to A, and then you doubled it, you get to A prime. So when you trace out like a segment to B, if you just double it, you get to B prime. And if you trace out something to C and you double it, you get to C prime. Same thing with D and D prime. You still get something twice as big, just not centered around the original shape. Not every time, unless the original is centered at 0, 0. Okay, so there's 5. So in 6, we want to stretch a graph again, but this time we don't want to stretch it in all directions. We just want to stretch it horizontally. Okay, so if you want to stretch something horizontally, and in this case we're stretching it so that it's 3 times as far away, 3 times as long, right? So instead of like 1 unit out on this circle, it's 3 units out on the circle. But notice the heights stayed the same. This height to here, that stayed the same. And this triangle's height right here, that didn't change. Those are the same height right there. So really when you want to stretch something out just in the horizontal direction, the only thing that's going to change are your x values. The y's stay the same. So I'm going to make all my x's 3 times as big, and all my y's I'll keep the same. So this represents a horizontal stretch by factor 3. And if you wanted to stretch something vertically instead, so that like a circle turned into something like that, well then you're going to do something along the lines of like xy turns into x comma 3y or 2y or however much you wanted to dilate that by or stretch that by. Okay, So I think up to there, most of those seem fairly intuitive to most students. The rotation ones are a little bit harder. So in this one, if I take the point 4, 1, hold on one second here. Okay, sorry about that. So if I take the point 4, 1, and I want to rotate it 90 degrees counterclockwise around the origin. So there's the origin, 0, 0. And here's 4, 1. And if I rotate it at 360 degrees, you can kind of picture that you're going to get a circle going around here. Let's see. A little bit down there, and then it comes back around. So 360 degrees would take me right back to A. If I just wanted to go 90 degrees, that's a quarter of the way around to the circle. So I'd end up like around here somewhere. So what we're doing is we're rotating 90 degrees this way, which actually makes this angle in the middle 90 degrees. And so one thing that we can do to figure out where that image point ends up, other than just trying to eyeball it, is by saying, well, we know that perpendicular lines have slopes that are negative reciprocals. And if you tried to figure out this guy's slope, well, it's 4 across and 1 up. So this guy's slope right here is rise 1 over run 4. So 1/4. So then this guy's slope will have to be the negative reciprocal of that. So this guy's slope should be negative 4 over 1, which means I'd have to go down 4 units and then over 1 unit to get back to the origin, which then if you count from the origin backwards 1 and up 4, this point right here, A prime, has to be at negative 1 comma 4. So the 90 degree counterclockwise rotation took A, 4, 1, to A prime, negative 1, 4. So if you, let me make up another point. What do you think would happen to 7 comma 3? Well, notice the x and the y's kind of got switched here. So if I switch them, I get 3, 7. But then notice the 1 became negative. So the 3 in this case would become negative. If I did it with a general point, then I would get, sorry, I had to pause it for a second. If you try the same thing with a general point, x comma y, then that's going to turn into, well, it's kind of like flipping the coordinates, but then notice the first one, this one, when it went over here, it changes signs, so I'd need to throw a negative in front of there. So this right here, whoops, is the rule, so this represents a 90 degree counterclockwise rotation about the origin. Okay. So in number 8, we're going to do this again. Let me actually do this to save a little time. So I'm going to copy this and then paste it down here if I can. And move it right on top of this guy. Okay. So we already know that if I rotate it 90 degrees, I end up at A prime, which is negative 1, 4. If I wanted to rotate it another 90 degrees, that's like rotating by 180. So if I rotated another 90, I'm going to end up at, and I can't call it A prime, so what a lot of books do is they call it A double prime. And then if I rotated another 90, we'll call this one A triple prime. And then if you rotated another 90, you end up back at the original spot. So we're just doing rotations by 90 over and over, so I'm just going to keep using this rule. So A prime we already have is negative 1, 4. So if I apply this rule to it to rotate by 90 degrees more, then I switch the x and the y, so it becomes 4 and negative 1. But then I have to throw a negative in front here, so it becomes negative 4, negative 1. And if you look at where that point is, it looks like it's at about negative 4, negative 1, which is where it is. Some people notice that a rotation by 180 from the original point, 4, 1, it's just negating both the x and the y. A triple prime we'll just take a double prime and rotate by 90 more. So -4, -1 turns into a triple prime by rotating by 90. So I'm going to apply this rule again. X ends up in the back, Y ends up in the front. So -1, -4. And then you got to switch the sign, so it actually becomes +1, -4. So this is at 1, -4. And if you graph it well, you can tell, yeah, that looks like it's in the right place. And it happens to be the exact opposite of 180 degrees away from it. Okay, so I'm going to pause for a little bit, and I'll come back to this later on. All right, so the last part of this video is going to be on the last page of 7a, and this is kind of the putting it all together. So in this one, I'm not going to worry about these graphs down here. Really what I want to do is figure out how do these transformations change that point. And the idea is I'm going to take this point and then stretch it by 2 and then take that point and shift it 3 to the left and 5 up and continue on, and it's sort of a chain reaction, and the goal is to figure out where the final point ends up being. So let's look at what these things do. So a horizontal stretch by a factor of 2 means you're going to take the point that you have, and if I'm only stretching it out horizontally, only the x values are going to change. So I'm going to double the x but keep the y the same. So in fact, I'll just write the rules here informally. Double x, right? When I shift it 3 to the left and 5 up, 3 to the left means I'm going to have to subtract 3 from x, and then 5 units up means add 5 to y. If I'm vertically shrinking by a half, that means that I'm only pushing things in towards the middle vertically. So that's going to be multiply y by 1/2. When you reflect across the y-axis, so I'll use one of these graphs down here. So if you reflect across the y-axis, notice the only thing that changes here, the y values stay the same. It's the x values that change. So this one would be change sign for x. And then the last thing, rotate 90 about the origin. That's the one where you take xy. We just did this. Take xy and turn it into -yx. Okay, so let's apply that by starting with our point C. So C is at 3, -1. So if the first step is stretch it by a factor of 2, you have to double the x. So if I double the x, I get 6, and then I keep the y the same. Then I'm going to shift it 3 to the left and 5 up. So I'm taking this point now and subtracting 3 from the x and adding 5 to the y. So -1 plus 5 is 4. Then I'm vertically shrinking by a factor of a half. So I'm going to take the y value and shrink that by a half, so it's multiplying it by a half. I'm going to get 3, 2. Then I'm going to reflect it across the y-axis, which means change the sign for the x value. So instead of 3, 2, I'm going to get -3, 2. And then the rotation by 90 degrees. When I don't mention a direction, it's assumed that it's counterclockwise. So that's going to be, it's kind of like flip the x and y and then throw a negative in front. So flip the x and y and then throw a negative in front. So there's my final point. That's going to be my C prime. Okay. And then the one other thing we did in class, we didn't bother with the graphs. The graphs were there to show you what happens at each step, but I'm not worried about that. So the last thing was to perform the same transformations, but now do it on 3 other points. And really all I wanted to do was preview how to do it with some point that has no specific numbers in it. So I'm going to, let's see if this works. I'm going to take this, edit, copy. I'm going to paste it down here somewhere so we can see it. Edit, paste. Okay, let me move this over. So I'm just going to put it down here. Okay, so if we did the same thing, but with the point A, B. So the first thing was stretch it by 2, which means double the x value. So that's going to turn into 2a comma b. And then we're going to go 3 to the left and 5 up. So I got to subtract 3 from the x value. So 2a minus 3. And then add 5 to the y value. So b plus 5. And then we're going to shrink it by a factor of a half. So I multiply the y by a half. Well, there's my new y value. The x stays the same. And then multiplying by a half is the same as dividing by 2. So I'll do b plus 5 all over 2. Okay, then reflect about the y-axis. Change the sign for x. So this is going to turn into negative 2a minus 3, comma, b plus 5 over 2. And then the last step, I'll just go down like this. So the last step is rotate 90 degrees counterclockwise about the origin. You flip the x and y and then throw a negative in front of the first coordinate here. So if we switch them, we get b plus 5 over 2, and then negative 2a minus 3. And then you got to throw a negative in front of that first coordinate. So right there, I'll put this in parentheses so it's more obvious. So that means that AB ultimately turns into this guy right here, negative b plus 5 over 2, comma, negative 2a minus 3. And so the reason this is good is if you had to do this process for like 6 points or 5 points, a bunch of points, it's somewhat annoying to go through it every single time with every point. But if you do it one time with this general point that has no specific numbers, you get a formula for what you can just plug those numbers into and you're done. So like we'll do it with the point that we already checked, 3, negative 1. C was 3, negative 1. So if I try this right here, let me get rid of this now. So cut. Oh. So if I try it with 3, negative 1, A is 3, B is negative 1, and then that's going to turn into negative b plus 5 over 2, so negative 1 plus 5 over 2, comma, negative, and then 2a minus 3 is 2 times 3 minus 3. And if you work that out a little bit, so this turns into negative, let's see, that'll be 4 over 2, so negative 2, comma, and then this inside the parentheses here is 6 minus 3 with a negative in front, negative 2, negative 3. Well, that's what we got here. So so if you had to do it several times, and in this case we were going to do it with these 3 points, but we ran out of time in class, the idea is you can just do it once with the general point and then use that as your blueprint for how to plug in any point that you want and see where it ends up. Okay, so I hope that helps a little bit, and I'll see you guys in class.